So thank you everyone for joining. Myself, Zahid Bashir. I am a faculty member in Department of Commerce, University of Gujarat, and I am a PhD scholar in Delhi College of Commerce, University of Punjab. Today, I am going to discuss the basics of panel data analysis. And in my previous session, I have discussed some important things using this document. I have discussed some basic things about panel data, like what is panel data, what is the difference between a short panel, long panel, the basic consideration of panel data, uh, like long versus short panel, like balanced versus unbalanced panel, and what are their particular characteristics with respect to panel data. Then I have also discussed the fixed versus rotating panel data. These are the things that basically are required uh, for the estimation of panel data. So today I will discuss some basic considerations of panel data. I have also discussed the basics of panel data models like pooled OLS. If you would like to apply the pooled OLS, you need to understand that in that case, uh, in that case, you assume that there is no cross-sectional or time-specific effect, and you are considering these assumptions for the application of pooled OLS. So we will try to find out how these assumptions would be tested. Then we have discussed the difference between fixed versus random effect. In case of fixed effect, the cross-sectional or time series effect is measured or estimated along with your beta naught or alpha part, while in case of random effect, your cross-sectional or time series effect is estimated on error term. So that is a theoretical difference between both of these considerations. So you need to understand that how you can apply the particular commands on fixed effect and random effect so that we can apply them correctly. So there are some further considerations that you need to understand. The first one is the functional form. So whenever you need to apply the fixed effect model, the basic construction of your model would be YIT is equal to A plus UI. A is basically the beta naught, the first part of your model, while UI is basically the cross-sectional effect or time series effect on your constant term. So in case of fixed effect model, there might be some effect, the fixed effect of cross sections or time series on your constant term. While in case of random effect, that fixed effect, which is due to some cross section of or time series, it 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 it, it basically affect your you can say error term. So it becomes random effect model theoretically. What are the further assumptions that you need to understand with respect to fixed and random effect? These are like you need to see whether individuals' effects are correlated with regressors or not. You need to find out whether your individual effects they all right, I have connected again due to some interruption in internet connection. I was away for a short break, so I have connected again. I was telling you that there is a difference between the theoretical foundation of fixed effect and random effect model. So, in case of random effect model, it is assumed that individual effects means heterogeneity is not correlated with any regressor. Regression means independent variable. So, in case of your random effect, your individual or cross-sectional effect would be considered for error term only. They would not be considered for your regressor or independent variables. So and then estimate error variance specific to group. Hence, UI is an individual specific random heterogeneity or component of the composite error term. So this is why a random effect model is also called an error term component model, because your fixed effect is goes into the error term component of that model. The difference among individual period is lies in the individual specific error. So these are some consideration that you need to understand. So random effect model reduces the number of parameter to be estimated, but will produce inconsistent estimate when individual specific random effect is correlative with regressor. So you need to understand some of the basic things using this document. So fixed effect are tested by F-test. It is provided as a part of your regression analysis using Stata. So we will use it and we will let it know how these considerations are used. So I will explain this in further detail time by time. By today, we are going to start the part of Stata, how we can make decisions about Stata, how we can consider Stata for our basic estimation. So this is the document I have prepared for guiding you how you can apply the step-by-step procedure for understanding the Stata framework. So first of all, you need to understand this particular framework in order to understand how you are going to apply the panel data analysis. So at first part, you need to understand the first row of rectangle. If you see the first rectangle on the right side, on the very right side, it is indicating that if your time dimension is less than 25, and your number of individuals or countries or firms is also less than 25, then you should use static panel regression estimations like pooled OLS, fixed effect, random effect. So let's suppose that we have 20 country or 20 firms data along with 10 years time period. Now, this is the case where it applies with this condition because time dimension is less than 25 and number of cross sections or number of countries or number of companies is also less than 25. In that case, we need to consider either the pooled OLS or fixed effect or random effect. But in case if you have the time dimension greater than 25 and cross section less than 25, it means you have more time frame and you have less cross sections. In that case, you need to apply the first generation panel. um, Here, the first generation panels means that you are going to apply the unit root testing, that is panel unit root, because you have higher dimension of time series here. So in that case, you need to apply the first generation panel unit root test. If your dependent variable is stationary at first level and your independent variables are stationary at first level too, then you are going to use Pedroni, Fisher, Cow co-integration test. In the same way, if your time series is less than 25 and your cross sections or number of countries or number of companies is greater than 25, you are going to check endogeneity first, and then you are going to use the GMM as a solution of that indigeneity. So you need to understand that your time series should be less than 25, while your cross sections or companies or countries should be greater than 25 in order to consider this condition. Uh, all right, there is a question. DV first stationary means, I will let you know, maybe you are not aware with the stationarity. I will let you know when I am going to test the stationarity testing. I will let you know what is means by first level, what is means by zero level, what is means by two levels. I will let you know. Because when I am going to apply the procedure, the panel stationary testing, I will let you know the whole idea, what is mean by DV1, IV1. So the next thing is that you need to understand if your T is greater than 25 and N is also greater than 25, then you are going to test the cross-sectional dependence test. If you find cross-sectional dependence, then you are going to use the second generation panel unit root test using the following procedures that are available here. The first is if your DV is stationary at zero level and IV is also stationary at zero level, then you are going to use common correlation effect. And if your DV is stationary at first level and IV is mixed, maybe it is stationary at zero, maybe it is stationary at one, or maybe it is stationary at mixed level. Then you are going to use dynamic common correlation effect. I will let you know how we are going to apply this procedure. But if your CD test determine that there is no cross-sectional dependency, then you are going to use the first generation panel unit root test like IPS and Lin-Levin method. Here you might have, if the DV and IV both are stationary at zero level, you are going to use pooled OLS, fixed effect, random effect, or seemingly unrelated regression, which is also called the SUR regression. And if your dependent variable is stationary at first level and IVs are stationary at mixed level, you are going to use the panel ARDL using PMG, MG, and DFE. So I will let you know step by step the whole procedure. First, we are going to consider this one where T is less than 25 and N is also less than 25. So we suppose that we are considering this one as a starting point. So how we will deal with this? So I am going to share with you a data set for your consideration. I am going to share it with you. This is the data set I have recently used in one of my studies, and I have extensively used this data set for my panel data analysis. So there are a lot of companies that basically are here as a middle income countries. There are approximately, if you can see the ID variable or ID column, you will find the number of companies here. So I have used here how many companies? 53 countries I have used, approximately 53 countries. And if you see the time dimension, I have used, let me show you. Let me show you from the first time dimension is from 1980 to 2020. This is a 40-year period. So if we go to the condition here, we should have T less than 25 and N is also less than 25. So this data set is not appropriate for this condition. Let me use another data set like if we are going to use the high income country data. Let me check how many years are available here. There are 90 countries, 19, which is less than 25. And if we see the timeline here, it starts from 2000 and it ends on 2021. And it is less than 25 actually. So it is almost 22 years period. So this data set is basically appropriate for applying the first condition because we need to have t less than 25 and n less than 25. So in our case, the t is approximately 22 years. If we count from 2000 to 21, it becomes 22 years, which is less than 25. And if we see the number of countries here, the number of countries is basically 19 here, total 19 companies. So it means that we are going to apply this condition on this data set. So let me share this data set with you so that we may be able to apply this procedure. So just a minute. I need to create a new sheet. Example data set for n less than for less than 25. All right. So let's suppose this is a demonstration data set that you are going to use for your analysis. So let me copy this data set because there are a lot of tabs here that would make you confused. So I am just going to copy this data set for your consideration so that you may be able to use them instead. So copy this data set and I am going to paste this data set here like this. And let me close the original file and let me share this one with you. Example data set. All right. So you can easily use this data set for your practice. And let me also share with it an option this way. All right. So let us use this data set for our consideration. Let me open the Stata file from here. All right. So we are going to use for our first instance this data set. So let me open the data editor because here we need to copy this data set. Always remember that the name of the country is not required in case of Stata. You just need to copy the data from the IDs like this and along with the variable name. So just copy from the column where the ID is located to the variable. Just copy them and just paste it here. It will ask you whether the first row on the clipboard contains values that can be used as a variable name. Yes, the first row is the variable name. So it is copied here. Please, Vakar, let me know, have you copied the data set into your Stata file so that I can proceed further? All right, all right. So let me start the procedure. The the variables are located here. You can see the ID, the years, the FDI, the financial development, uncertainty, capital formation, sustainable economic growth, GDP growth rate, GDP per capita, that is trade openness, inflation rate, exchange rate, and real growth rate. All these variables are extracted from WDI. If you would like to extract the variables data, you can search it for WDI. This is basically a database which is used for most of the macroeconomic variable. For example, if we see our data set, if we see our data, there are a lot of variable, for example, like capital formation. This is a variable, capital formation data. If I search it, it will show the World Bank database for downloading this data. You can simply click on it and you can simply download the data from here. There are option of Excel, CSV. So I have downloaded data variable wise and then I compile this data into this shape. So it takes a lot of time because you need to download data one by one and then you need to arrange this data in this form so that this data can understand the data more accurately. So it took me about 1 to 2 days to download and to arrange the data set like this. And I need to compile it according to the name of the country and according to the years. So it took me a lot of time. So let me start the procedure. We are basically going to fulfill this condition because our time series is less than 25 and our number of countries are also less than 25. So we are going to apply this procedure. If we see here, it is also you can verify from here that how many countries are there. You can see here the IDs and the years. So there are 22 years data with 19 basically the countries. So this condition is fulfilled. So we are going to apply the procedure. So let me start first. The first thing that you need to understand is that you need to tell this data that you are going to use the panel data estimate. So first command is xtsec. Then you need to tell your cross-sectional variable. And then you need to tell the year. If I copy this command from here, I will put it into here. Always remember that Stata does not accept anything as a capital letter. So try to make it smaller, XP set. Now you need to see is your data is related to some firms. Here the data is related to countries. So I have used country IDs. So you just need to replace firm ID with simple ID. You just need to click it here and it will become ID because I have available the IDs of the country. If you see in your data editor file, you can see here that I have coded the name of the countries with 1, 2, 3 digits. So I have named their IDs or their digits as a ID. So I am going to use ID instead of firm ID. Then my second variable name is years. So I have used it already. I have used it here. So you just need to enter and it will recognize the panel variable and it indicates that it is strongly balanced. So what does it mean by strongly balanced? Previously, I have discussed with you the balance panel data command. It means that when you have the data for a number of countries and for these number of countries, the data is available for all years, for all of the countries, then it is balanced panel. So this data indicates that it is a balanced panel. It is a strongly balanced panel. And it is also indicating that we have a year category from 2000 to 21. So in this way, this data has understood the panel. The next thing that we need to understand is that we need to check the summary statistic of our data. Usually, when we use the sum command is used to check the summary of your variable. That what is the minimum value, what is the maximum value, what is the standard deviation, etc. You can simply enter it and you can see it like this. Here you can find the mean values, you can find the minimum and the maximum values. But in case of panel data, this sum commands become xtsum. So you need to use xtsum instead of simple sum. So if you have the pool data, the sum command is reasonable to use. But if you have a panel data, you should use xtsum command. So you need to copy here your variable, and it will show you the summary statistics like this. Now you can see a detailed summary statistic. For FDI, the overall mean is 0.95, which is basically same here with the simple sum commands. But in case of XT it is shown the between the within effects, like between effect is used when we are going to analyze the FDI between different countries. So between different countries, there is a standard deviation of FDI with 1.185365. The minimum value between different countries would be 1.60. The maximum value would be this. The number of observation, the large N is basically the number of observation. The small n is basically the number of countries. So there are 19 countries. There are 22 years time period, and there is 418 number of observations. So here we can see how the summary statistic can be computed or descriptive statistic can be computed in panel data setting. The next thing that we need to understand is basically the correlation. Always remember that correlation would be same whether you are analyzing a pool data or a panel data or a time series data. It would not change. So we are going to use the same command for our correlation that we have previously used. So PWCORR, then you need to put your set of variables here like this. Then you need to put here star 0.05, then 6. And it will indicate the significance of variable like this. So you can compute your correlation values here. Here you can see that financial development is positively correlated with FDI. In the same way, if you can see that uncertainty is weakly positively correlated with financial development, and so on. You can interpret the values in the same way that you have done previously. You can also verify the multicollinearity issue here. Always remember that multicollinearity is assessed between independent variable only. Do not consider the multicollinearity between independent and dependent variable. Here, FDI is basically dependent variable. So we need to ignore the first column. The first column here, like FDI related column, you need to ignore. And you need to see the other columns for multicollinearity. If you remember, I have told you that for checking the multicollinearity, always remember that the correlation coefficient uh, should be 0.80 or greater for checking the multicollinearity. So if the value is greater than 0.80 or greater, and it is also significant, then there might be an issue of multicollinearity. If I see from the second column, like uncertainty is significantly correlated, but the correlation coefficient value is less than 80%. So we can ignore this because this value is less than 0.80. Although it is significant, but it is less than 0.80. In the same way, if I see capital formation with FD, it is also significant, but it is less than 0.80. So we don't need to worry about any value here. There is only one value which may cause the disturbance here. If you see this value is basically the correlation between GDP growth rate and the sustainable economic growth. So it shows a multicollinearity issue here because this value is greater than 0.80 and it is highly significant. So there is a multicollinearity issue between sustainable economic growth and GDP growth rate. So I have told you the remedy for these things. In case of multicollinearity, always remember if you are using the panel data, it automatically resolves the multicollinearity issue. So we don't need to worry about this multicollinearity because we are using the panel data estimation method. So we don't need to worry about this multicollinearity issue here. Then you can see GDPPC, that is GDP per capita, and there is no issue of multicollinearity here. Then trade openness, you can see that there is no multicollinearity issue here. Then you can also see inflation rate, and you would find that there is also no multicollinearity issue here. Exchange rate, if you see there is no multicollinearity. Real growth rate, if you see here, there is no multicollinearity issue here. Then you can also see exchange rate, no multicollinearity issue here. Real growth rate, no multicollinearity issue here. We only find one more multicollinearity issue, but as I have told you that we are using panel data estimate, so we don't need to worry about this. We can still report this correlation in our estimation. So after doing this, what I need to do, as we have fulfilled this condition, we are going to use either pooled OLS, fixed effect, or random effect. So I will let you know how to start the procedure. This part is basically relevant to testing the fixed effect, random effect, and pooled OLS. So these are basically the static panel commands. As we are assuming that our data is either estimated by pooled OLS or fixed effect or random effect. So let's start the procedure. Always remember, if you are using the Stata, you are going to start your procedure from fixed effect model first. So this is the command xtrect dv iv and then fe for fixed effect estimation. And then you need to use estimate store fix for storing your results. So as the time is less than 1 minute, so kindly join the meeting again using the same link so that we can proceed further. So please join this meeting again, Vakar, so that we can proceed further because there is 20 minutes left for this session. So join the meeting again. I am waiting about Tanan Aksar.